For the clamping arrangements for both the forks and the stem, I need to do a couple of things. Ultimately, I'm going to need to cut a slit from each of the relevant holes to the outside of the yoke to facilitate some movement for the clamping effect to work, and I'm also going to need to drill and tap the holes for the clamp bolts. Not for the first time, I am pushing the capacity of my milling machine. As we can see, I've got the yoke clamped onto the table. A little bit about the clamping setup. I've got an angle plate here which is set at 90 degrees to the x-axis, so that is aligned front to back with the y-axis. I have a square clamped to the table to provide a reference point against which the yoke is now positioned, and I've got a clamp here which is secured through one of the fork holes. I've also got this rather crude G-clamp here giving some extra clamping force, and I don't know how visible it is, but down in the bottom right hand corner I've also got another piece of stock clamped against the angle plate to hopefully stop the yoke moving when I start to cut it. What I'm going to do first is I'm going to find my reference point, which in this case will be the front edge, this edge of the yoke, and also the bottom or the top of the clamp, it doesn't really matter. Once I've got that established, then I will use a slot drill to cut a hole for the head of the bolt, the Allen cap bolt, which will be used to secure the clamp itself. Once I've used the slot drill, I'll have a nice flat surface from which I'll then be able to drill and ultimately tap the hole. Once I've got the hole drilled and tapped, then I can consider using a slitting saw to put the slit across. We're all set up to go. After having found the front face and the top face of the clamp, I've now positioned the quill in the right position, which is 55mm from front to back and midpoint in terms of depth, so 12.5mm on the fork clamp. You can't see that from your position. The hole needs to go down to the midpoint of the fork clamp, which is 27.5mm radius from the top point here. I've got the numbers set up in the DRO, so it's just a case of doing the cut. That seems to have gone without any major drama. It's quite a snug fit, which was intentional. I may end up having to trim the heads on my bolts. Okay, now I need to drill the full depths and tap it, so I need to change the setup in the mill. The chuck is now in the quill. I've refound the respective reference points and the quill is now directly above where the hole needs to be drilled. So this could be a very simple operation of centre drilling, pilot drilling, and then drilling out to tapping size. I'm looking for an M8 hole, so it's a 6.8mm tapping drill required. So we'll just run through that very quickly. The first part of that hole, basically from the flat I've cut with the slot drill down to where the slit will be, needs to be clearance, and then the threaded part will be from the slit downwards. I think what I'm going to have to do is just tap the hole with the full depth, so I don't think I'm going to get an 8mm drill in here to drill the clearance. The other challenge I've run into is that my 8mm taps, the first of which is in the mill at the moment, actually expand out on the diameter, so they're only going to go in about 25-30mm and they need to go in 40mm. So a couple of challenges to overcome, but that's what it's all about. So let me get the thread started at least in the milling machine, then I'll probably move it to the bench and use a normal tap wrench to bring it all the way down, or as far down as I can get it. So experience has taught me that aluminium, being very sticky, can be a pain in the ass to tap. So it's really important that I do a cut and then a back off to remove the cut material. So this is going to take quite a while. This is not a point at which I want to be breaking a tap. So you can see I'm doing a small cut there, back off, and even that's tight, back in, small cut, back it off. I've checked the diameter of the shank for the tap and it's 8mm, so once I can get my clearance drilled for the first part, then I should, well, hopefully be able to get the tap all the way down. Of course I'm also going to be limited clearance wise for the tap wrench, but I do have other wrenches that this will be less of an issue with. I did a bit of a trawl on the internet because I was very nervous about tapping this. The issue that occurs with tapping aluminium is that the swarf, the chips, stick to the tap and then they don't want to move, and that's when it all gets very tight and taps are easily broken. The general consensus therefore was lubricant and a good choice of lubricant. So I'm using one of my least favourite products. I really don't like WD-40, but I'm using that, and in all fairness it does appear to be working. I'm not getting anywhere near as much stiction as I would have done previously. We'll take this tap down as far as I can go for now and we'll see where to go from there. For the stem clamp I'll be taking the same approach as I have already done for both the fork leg clamps. So I'm going to use a slot drill to cut the recess for the bolt head first, followed by centre drilling and then drilling through and then tapping. The final drill here is 10mm diameter. That's my clearance for what will be the first half of the clamp. With the hole now drilled out for tapping drill size for the bottom half, the top half, as I've already said, is clearance. So I'll now at least start the tap. Yet again I'm pushing the limits of my tools. This is the biggest tap that will fit into that little chuck, my little guide there. I may struggle. But if we can get it started, again I can get it on the bench and finish it off. Just finishing off the thread. I've already run the first and the second tap down through, not quite all the way. I'll do that now with the plug. As with the fork leg clamps, going very carefully, although I've got a good layer of WD-40 on the tap and within the thread itself. I really do not want this snatching and holding and ultimately breaking the tap. So the plug is going down most of the way quite easily. As I've already run the second down, I only expect the plug to be doing the very last bit of thread at the very bottom. I've not got much to play with at the top. I think I'm through. Yep, there we go. Perfect. Finish the clamping elements of the yoke, I need to use a slitting saw to cut a slit for the stem. It will be midpoint in the clamp area, so coming out from the rear of the stem hole itself and extend into the back. For the fork clamps, I'm undecided. My original design had the slit effectively coming off the bottom of the diameter in this orientation towards the back of the yoke. To get that exactly on the bottom will cause a bit of a challenge with the slitting saw. So my thinking now is actually to raise that up maybe 5mm from the bottom there, extending backwards. I need to give it a little bit more thought. My real challenge though is I don't actually have the right size slitting saw. I've got something big enough in terms of diameter here, but it's only 1mm thick. I'm not sure that's going to work, so I've ordered a 2mm thick disc to give a thicker slit effectively, and I won't get that for a couple of days. So I'll wrap this video up here. Going forwards then, my next video will be the cutting of those slits, and that will allow me actually then to do a proper trial fit on the bike, which will be good. And then beyond that, really I'm into cosmetics. I think I do need to do some more work to pretty the lump up. It's still quite ugly and ungainly, so I need to think about how I can do that, and also at the same time look to continue to remove some mass, some more of the aluminium from the block, because it's still quite hefty compared to the original.